Hello guys, welcome to another tutorial series. What we'll be talking about today is how we can build a joystick control ROC car using Arduino and NRF24. So basically what we want to achieve here is build an ROC car that we can remotely control wirelessly using this RF module. This NRF24 module is a wireless transmitter which is capable of transmitting a short range. There's another version of this which we'll also use in this tutorial which has antenna. So basically in this tutorial we are going to be designing the transmitter first before the receiver. So the transmitter is the session we are going into right now. So basically this is it. So we'll just start our building. So what we require for this tutorial are Arduino Nano. We have a NRF24 module, which is this. As you can see here, these are the pin out. Just in case you're confused about it, these are the pins and this is the pin out. So this is how you wire it. If you have to wire it, you follow this pin out schematics. So we need a joystick, which we'll be using for the control of the ROC car. This is a robot car that will be manually controlling, so we need a joystick that will help us do that. That's where this joystick comes in. So we need a breadboard and we need jumper wires basically. So right now let's just dive into the step-by-step connection. So first and foremost, we're going to start with this. So right now these are the requirements for the transmitter session. We need this Arduino Nano, we need the NRF24, then this is a joystick from the top view. So these are the pinout of the joystick, which is clearly stated here for clarity's sake, just in case you're confused about it. If you have yours, you can just look at this section where it is being covered here. Everything you see here is stated here. So you just have to follow the pins the way they are there. So ground has been connected to our joystick. So the next will be to VCC. And VCC is also connected to VIN of this 5 volt. You can also connect this to our 5 volt terminal. We have a 5 volt on this. This is a 5 volt. You can connect this to that as well. Or you can also connect it to this VIN. Doesn't really matter. As long as you're giving this 5 volt to work, it will work perfectly. So the next will be to connect our VRS, which is this. So our VRS has been connected to A0. And the next one is our VRY, which is connected to A1. So it has been connected, as you can see. So right now, the session for this joystick is fully connected. So what we need to connect next to this Arduino Nano is NRF24. Like I said before, at the beginning of this tutorial, these are the pinout of this module here. In order for you to understand how you need to connect this, you have to understand this pinout. This one here is our ground, and this is our VCC. These are CE, these are CSN, these are CSK, which are clock. These are MOSI, which is this, and these are MISO, and these are RFQ. So basically, we are not going to be using this pin 8, but we'll be using from pin 1 to pin 7. So right now, let's start with the ground connection of this RF module. So ground has been connected to ground, and we'll be connecting the VCC to pin 3.3 volt of this Arduino Nano because this NRF24 module only need 3.3 volt maximum to work. It's a low power consumption module that when you use in appliances, the internal battery of that appliances is going to last longer because it consumes very low power in order for it to function well. Though there are converter module for this where you can just supply 5 volt and that module will supply this steady 3.3 volt. But since we are not using that converter module in this case, don't make any mistake of connecting into 5 volts or VIN. On powering that device, this will just go a wire to fry up and you've lost that module already. So let's connect VCC. VCC has been connected to 3.3 volt like I said. So the next one is CE. C is connected to D7, and the next one is CSN, which is connected to D8. The next one is the clock, connected to D13. The next one here is Miss Mosi, which is connected to D11. Next one is our MISO, which is connected to D12. So right now, the connection for this terminal of this module to Arduino Nano has been fully connected. So what we need to do now is supply power to this device. Arduino need power. Our NRF24 needs power. Our joystick here needs power. So we're going to be supplying a steady 5 volt to the V-in of this Arduino. So the Arduino is going to supply this 5 volt and supply this one 3.3 volt, since we are connecting the VCC to 3.3 volt terminal. So right now the power supply has been connected. This is the positive and the negative. This is the power jack. So you can supply between 3, as in 5 volts to 9 volts. You can even supply from 3 to 9 volts to this Arduino. But since you are supplying it to V-in, you start with use a steady 5 volt. I don't advise you using a 9 volt. Just to be careful. Use a 5 volt power supply and connect to Arduino. So we've already connected the negative of this 5 volt power supply to Arduino ground. So the next will be to connect the positive, which is the VCC, to our V-in. So right now, the V-in is sharing a common terminal with the VCC of this joystick. So 35 volt is going there. If you are supplying more than 5 volt to this V-in, please connect your VCC to plus 5 volt here. Please take this as a note. So you won't say I made you destroy your component. If you are connecting 9 volt battery to this Arduino Nano, connect your VCC of this joystick to what? Pin 5V, which is 5 volt here, in order to avoid you damaging the ICs on this joystick. So that is for that. So what we need to do right now is what? Upload the Arduino code of this transmitter to this Arduino in order for this to be concluded. So once we are done with this, we move over towards the section of the receiver. So we'll do the connection for receiver. So right now, let's just do the Arduino upload. So I will just load right now. Let me just, so basically, this is the code we'll be using for the transmitter. This is just the code. Basically, what we need to do right now is just copy it, then move to Arduino IDE that is opened. This is a blank file. You just paste it. Make sure you delete everything that is there. You paste. Basically, what we will need for this to work is this theory library. You need to include the SPI library. You need to include the NRF24 L01 library and the RF24 library. So these are the theory library that is required for this to work. So basically, for this NRF, the major ones here are connected to, which is our CE and CSN. It's connected to pin 7 and pin 8. So these are just the constant that needs to be followed. So this, like I said before, this is the transmitter code. So all we need to do is to what? If you don't already have this installed, go to library here, just type this. You can just copy it and paste it here. The system is going to search. If you don't have it already, it's going to search for it and install. Once you see it, you install. But I already have it installed before now. So you copy every one of them like this as well. You can just copy it. RF. So as you can see, is installed. So this one, like I said before, you also copy, paste. That's all you need. Then, so this is it. It's stored already. So what we just need to do right now is go to Tools, go to Board, Arduino, go to Arduino Nano, go to Tools, Port, then select the port. In my own case, is on port 8. Then what you need to do is hit the upload button and just wait for it to upload. So right now it's compiling the sketch. As you can see here, it's compiling sketch, downloading the index redirect. So once the sketch is compiled fully, it will upload the code into the Arduino. And at that point, you can just detach the Arduino and what connect to your circuit. So let's just wait for it to finish. But this is basically what you need to do to get it done. So right now it's uploading. Once it is done uploading, right now you see say done uploading. So the code has already been uploaded. So all what you need to do is detach this and mount back on the breadboard in which you're connecting your Arduino. All your connections are already based. Every connection we've done already is connected to a section of a breadboard on our Arduino. So you just mount the Arduino back. Then what we need to do next is move on towards the receiver circuit design. So now right now at the background you can see that there's variation in what we used to have. So right now let's just go to the first step. The requirement we'll be needing for this is Arduino Nano. So we'll be needing two Arduino Nano in this case, one for the transmitter and one for the receiver. We already programmed the one for the transmitter. So this one right now is for the transmit is for the receiver. So we'll be needing the same NRF24 module. We need the DC geared motor. We need the gear motor wheel. So we need this driver, this L298N motor driver, the most commonly used RC car driver for DC motors. So we need chassis. In our case, this is a chassis for three-wheel drive. So we need a breadboard. This very breadboard is the mini one. This is the smallest form of breadboard that is existing currently. So there's one that is bigger than this one before the long breadboard. Excuse me. So we need jumper wires. Now, aside jumper wires, what we need to do right now is start the connection proper. So right now, as you can see, there are already connections in existence. This we already did before. The connection for this NRF module to Arduino for both transmitter and receiver is the same. So we don't have to go through this process of connecting everything all over again since we already did for transmitter not too long ago. So what we'll be doing right now is connect the extra components we have toward Arduino Nano. So right now, as you can see, the ENA, which is the first pin here, has been connected to what? D5. Now, in 1 is connected to D2. In 2 is connected to D3. In 3 is connected to D4. While in 4 is connected to D6. So in 4 has been connected to D6. So right now, virtually this side of the connection is almost complete. So NAB is connected to what? D9. We have NA, ENA, and ENB. These are the enabled pins for the first motor driver and the second motor driver. We have two output for the two motors we'll be using, which are these motors you see here. So enable 1 controls this, enable 2, which is enable B, controls this other motor. If you leave these jumpers on, they will not even rotate at full speed. So that is for that. So what we need to do next is connect this motor 1. So this is motor 1 connected. Positive and negative side of it has already been connected to this driver. So we connect motor 2 as well. Motor 2 has already been connected. So at this point, the circuit is almost complete. The only thing is lacking right now is power and the program for this Arduino. So what we need to do right now is move on to the power. But before then, you need to take note of this. It is very important. Now you see this arrow pointing here. This is the jumper here. It's like a fuse. This was on another jumper. These two jumpers are connected to ENA and ENB, the enable pins, which control these two terminals which the motors are connected to. So in order for us to make sure the two motors rotate at maximum speed, we have to make sure these two jumpers are removed. So always remove the two of them. If you are using just enable 1, you might not bother yourself with enable 2 jumper, but if you are using both motors, if you are using this terminal and this terminal, remove both. So that is what is written here. Remove both jumpers from ENA and ENB. So that is for that. So right now, the power is what we are connecting right now. So this is power, 8 volt to 12 volts being supplied. So in this case, we are supplying 12 volts. But if you use an 8-volt power supply, it will still work. The only thing is that this motor might not spin as fast as they should when you give it a 12 volt. But this motor virtually works from 4 volts up to start spinning. If you connect them to a power supply of 4 volts, they will start spinning on their own without any driver, basically. But that spin will not be at maximum speed. So always make sure you use a 12 volt power supply in this case. So we are connecting a 12 volt power supply ground to our ground of what? This. Now, if you notice, the ground was looped to the ground of what? Our Arduino. So this power supply is sharing common ground. Always make sure this is sharing a common ground between the Arduino and this driver. So the next one is the positive. Now, the positive here is going to what? 12 volt. You might ask, why is it not sharing the same positive with this? We don't need the same 12 volt at this V in for Arduino. We have a 5 volt terminal here from this driver. So it's safer to give Arduino 5 volts. It's not like if you put 12 volt here, it's going to blow up. No. There's an onboard voltage regulator that can give this device a steady 5 volt. As long as we give it a voltage that is more than 5 volt, the regulator will do the job for you. But to avoid overheating this Arduino Nano, we'll just take our 5 volt from here. So the next connection right now, as you can see, is to V in. Is connected all the way to what? 5 volt terminal of this driver. So the driver itself is receiving external source voltage 12 volt and supplying our Arduino 5 volt from its board, because this is the 12 volt ground 5 volt. This is the terminal. So our motors are getting 12 volts each from this 12 volt supply to this device, this driver itself. So basically, this is just the wrap up of the connection for what? Our receiver circuit. So what we need to do right now is our Arduino what? Code upload. So guys, right now our Arduino IDE has been opened. If you remember, this is our code for the transmitter section. So I'm just going to highlight and paste the receiver code. Don't worry, every code used here, both the transmitter and the receiver code, including the circuit diagram, will be what given to you in the description of this video. A link will be provided in the description of this video where you can download the circuit diagram and the code for each of the session, both the transmitter and the receiver. So basically, for the receiver, the receiver itself requires the same what libraries. Like I said before, the connection for the transmitter and the receiver in terms of the NRF24 is the same. So that is it. The only difference here is these are the pin declaration for the motor driver. The L298N driver is using this pin as they are defined here. ENA is connected to pin 5, in 1, pin 2, in 2, pin 3, in 3, pin 4, in 4, pin 6, enable B, pin 9. So if you are confused about the circuit, you can from the code here understand it. So all you just need to do next is what? Select your board, Arduino Nano, as you can see. You just need to go to Arduino boards, Arduino Nano, check it, then for the ports, you go to the same port. Mine is still connected to the same port, so I'm still using the same 8. So what you just need to do next is what? Hit the upload button. And once this code is fully uploaded, all you need to do is to power on your circuit and what? You're done. So right now it's done compiling, uploading code, done uploading. So at this point, everything that needs to be done is done. So let's see how the physical design works. So for the chassis assembling of this RC robot car, I have a video in in the description already. You will see it there where you can assemble the chassis of this Arduino RC car, because these chassis will not come to you assembled if you are buying it. They will come in parts. So you have to assemble the chassis using screwdriver and the rest, mount everything, then before you start doing your connection proper. Like I said, you have a video that will guide you on step by step on how to assemble both the 3-wheel and the 4-wheel chassis. I have video for that already in my YouTube channel, so do it to view those, watch those before you proceed to even doing all this connection, because the car will not assemble itself. So thank you for watching. Let's just move over to see how our ROC car performs. So guys, after our connection, this is what we arrive at. This is the transmitter and that's the receiver on the ROC robot car. So right now, let's just test. As you can see. So as you can see, it works. You can see it's spinning. So it won't look as if it doesn't work. So you can see it works. So this is just the test of our ROC robot car. Mind you, we'll be doing our next episode on this ROC car using the ESP now protocol. So we'll be pairing 2 ESP in the case of this RF module. So we'll be using ESP32 module
using the ESP now protocol. So one will transmit, one will also receive, just like this. The only difference is we'll be using this module we are using right now. As you can see, this is a transmitter. You can see it's having our antenna. See it? And that's the receiver. This is the receiver. You can see the module here. So right now let's just zoom back to the ROC car so you can see both. Right now both are visible. So let's try. This is it. So this is it working. So this uses the same protocol this my baby's car uses. So you can see this is a car. So the same protocol works both. So try yours out. Give me feedback in the description of this video. So if you like what you saw, do well to at least like, subscribe, share our video. Also hit the notification button so that whenever I post the next one, which we're going to be using ESP32 for, you'll be the first to get it. Thanks for watching.